Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question number 18 of NEET Physics paper 2017. Students, let us solve question number 18. The photoelectric wavelength of silver is this. So photoelectric wavelength is this. The velocity of the electron ejected from the silver surface, this is surface of silver, by UV light of wavelength is, so on this silver surface the lambda that is incident is 2536 Armstrong, and the on this silver surface the photoelectric wavelength, that is the photoelectric wavelength means lambda naught, threshold wavelength is 3250 Armstrong. So the any wavelength should be less than this value, so it is less than this number is less than that, so photoelectric effect will take place and electrons will start emitting from the surface outward. The velocity of the electron ejected, suppose this is moving with the velocity V max from the silver surface by this light is how much? So it will actually find the velocity of this, and that answer should be in meter per second. What is given is the Planck's constant, which is h value is this in electron volt seconds, not joule seconds. So when you require this value, you can put it, and C value is this. So if you go by general procedure, it will take time, and I will just tell you both the things. But first, let me solve this by a shortcut method. To find this velocity, we have to write the Einstein's photoelectric equation. Photoelectric equation, that is the maximum kinetic energy of the ejected electron is the energy that is incident minus the work function of the metal. This is the work function, this is the energy that is incident, and the difference is the kinetic energy. Now this equation can be written as half mv square v max square, maximum kinetic energy, is equal to E is hc upon lambda minus hc upon lambda naught, and h and c values are given. This h value is given in electron volt second. This is electron volt second, this is meter per second. Second cancels, so electron volt meter will cancel. If I keep it meter, then it will be electron volt. When I get this in electron volt, this also has to be converted into joule, so that the answer will be in meter per second. So first let me solve it by a general method that we generally do, as is given to use this h value is this one. So I'll write h value is 4.14 and it's given 10 raised to minus 15 electron volt seconds, and c is I'll write 3, this unit 3 into 10 to the power 8 meter per second. So this s is actually basically common, so I'll keep it outside, and inner side it is 1 upon wavelength lambda minus 1 upon lambda naught. This wavelength I write in meter, which is given meter. So this is my lambda and this is my lambda naught. If I substitute that, this I will just rearrange that. 4.14. You can see the second will cancel. This is the electron volt meter. If I write this in meter, this will also cancel. So there is no unit. So it is only electron volt 4.14, 10 raised to the power minus 7, because it's 8 here, into 3 is there, and into 1 upon lambda in meter is this is my lambda 2536, 10 to the power minus 10 minus 1 by 3250 and 10 to the power minus 10. So this is in electron volt, but this is in this has to be in joule, so I have to multiply that with 1.6 10 raised to minus 19. So this will become 4.14 into 10 raised to the power minus 7 into 3 into 1.6 10 to the power minus 19. This will become joule bracket. This 10 raised to minus 10 comes out, and this is left with 2536 minus 1 divided by 3250. This is in joule, and this is half of mv max square. I am interested in this one, so I have to put the value of m. The 2 goes to this side, m is divided, so I write v max square. I will use one line here. V max square is, the whole thing will remain as it is, and 2 is multiplied, so this becomes 6 here. So write 4.14 10 to the power minus 7 into 6, because this 2 is multiplied, into 1.6 10 to the power minus 19, divided by this m is divided this side. The mass of the electron is 9.1 into 10 to the power minus 31 kilogram, and this 10 to the power minus 10 is there, and this value will remain as it is, 1 by 2536 minus 1 by 3250. This is in meters square per second square, because this is square is there. So by taking the root of this, you will get the answer. First let me solve this part, which is minus 31, and this is minus 41. Minus 41 goes up, this is 26, this is minus 26, this will become plus 41. So minus plus 41, 1 goes, 25 is there, so 15 is there, so 10 to the power 15. So this will become 10, so this will cancel, and it will become 10 to the 15. So V max square is 10 to the power 15, I write first, into 4.146 1.6, 4.14 1.6, and 6 is there, divided by 1 2 3 9.1, and that's all. And this side is 1 by 2356 2536 minus 3250. This is actually 2536. Now if I put the, I'll have to take the square root, but before that I have to solve this. Then I have to take the difference, and these two brought out. So this is a very lengthy calculations. So, but we are interested in, if you see the options, then approximately the answers are given, because you should not go for actual calculations. If you go for actual calculations, it will take a lot of time. So just let me help you how to do that. Just I will go with the values. Order is important. Order I'll get, either it is the answers are in order is important. You can see 6 point something or 3 point something like that. So let me just try with whether I'm getting the answer or not. This difference I'll take first, and this is 1.6. So this I'll take with no hesitation. If I take this is 10, there is no problem with that. 9.1, I will take 10. Here I'll take 1.5, and this is 6.5 around. I'll take 6.5, 6.4, these two together. So this is 10 raised to 15 into these two together is 3 by 2 if I take, and 3 by 2, then 2 to the 4, so 3 to the 6, so around 6 point something. If I take 6 around, these two together I'll take 6, and this I'll take 9, this I'll take 6 again, and this one I'll take approximately, you have to calculate this, I'll take here 3250 minus 2536, because this is there actually, divide by the multiplication 3250 and 2536. If I take the root, then this value will be how much? Just let me use the calculator for that. The difference 3250. Just let me use the calculator. 3250 minus 2536. This comes out to be 714. So this, if I take this is 6 by 9, 10 raised to 15, and this comes out to be 714 divided by the product of that, and I'll take the product 3250 into 2536, that comes out to be 8242,000. But you can also go for this is 3250, and this you can take 2530. That way also go for the calculations. So if you do that, and V max will be the under root of these values. This 1, 2, 3, 4, 5, 6, 7. If I take it 8 here, then if I can cut up to 8 here, this is 8 and 10 to the power 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 8 10 raised to 6. This will become 9. Okay, 9 and 9. Then I'll put it here 6 10 raised to 9 into 7. I'll take 700, no problem. Divided by 9 approximately, and this is your 8. Then 72 here, I can write this as 72, 720 for my multiplication. 72, this is gone, and this is 10 left. This is 6 comes out, and this is 10 raised to 5 comes out. Approximately, as you can see that I calculated, this comes out to be 6 10 raised to 5 meter per second. If you see the option, then 6 10 raised to 5 meter per second, so option number 1 is correct. Approximately you will get in any way, because you should not go for actual calculations. You can see that 714 I have written to 720. Some part I increase, some part I decreases, and approximately I will get the number. Here 8242, I write this as 8 10 to the power 6, and then I manipulate 9 8 the 72, so I'll make it 72, because I am not interested in the number, I am interested in the power. If you keep the power correct, then you will get the answer correct. So this way you can calculate. Otherwise, there is also a method, short tricks. I'll just tell you here, and you try at home and get the answer soon, because that is more easier than this one. This is the general method. Another thing is that we know that energy can be obtained by 12400 divided by the wavelength in Armstrong. This would be in electron volt. So I have got two wavelengths. 12400 divided by one wavelength is this one. That is energy that is incident, 2536. 2536 Armstrong. So this you can calculate as 2500. Okay, for simple logic, approximately you can calculate 12400 divided by 2500 or 30, no problem with that. You can go for 30 or 00. So 20 cancels. This is 125 divided by 25. Approximately I will take this one also, 125 divided by 25. Approximately it is 5. Okay, approximately I'm getting 5 electron volt. So that way also you'll easily get the answer. The next one is that this is the energy incident, and energy, the work function I'll get as 12400 divided by this one 3250. Okay, this is the work function. So this 0 goes. Okay, 10 will go. 10 is left here. 10 is left here. So I'll write to 1240 divided by 325. Okay, what I'll do, I'll cut in with how much if I take 5 here, then it is 1250 divided by 325. I cut in 5, 25. So 25 3 4 4 13. 25 13 is how much? 3 5 is 15 1 7, and this is 5, this is 2. This is 5 325. So this is 13, and this becomes, I'll get 25 50. Okay, so 50 by 13, which is equal to 50 divided by 13 is equal to approximately how much I'm getting? Approximately it is 13 4s are 52. So it is little less than 4, or I write 3.8 something approximately. So this is 5, this is 3.8 I write. So the difference is how much? Difference is 1.2. So that is the energy I'm getting here, and kinetic energy half mv square v max square equals to this 1.2 into electron, that is in joule. This one is in joule, and I multiply 2 and divide by m. M is 9.1 10 to the power minus 31 kilogram, and I take the root, and this is the answer. This will how much? Then this is 16, and I'll take this is 16, this is 12, this is 9, this is how much I'll get? Then this is 2.4 into this, I'll take 1.5, no problem, and this I'll take 9, or I'll take 10. This is I'll take minus 19, and this is minus 31 root. This is 30 and goes up. This is plus 30, plus 30. So 11 is left. 11 is left. 10 to the power 11. I keep 10 and I give 0 to this one. So this is around 25, and this is around 1.5 root. This 5 comes out. 10 to the power 5 comes out, and this one is approximately 3 by 2. This is 3 by 2. 3 by 2 is 75 divided by 2, which is approximately equal to 2 3 is 6. 2 7 2 7 are some 37 around. I'll around take it is 37 root, which is around 6, around approximately 6. So what I'm getting? 6 10 to the power 5 meter per second. So this value, you'll get 6 point something, 0 something, 6.01, but I'm interested in the approximate values because the question is given approximately how much. This is approximately 0. This way also you can solve, but this will take a lot of time, and this one was much easier one. Okay, thank you.